This is the video for day 2 in Unit 5, and we're going to be doing something else that's review. So these are things that you've seen before, and we are going to be graphing systems of inequalities. Last year you learned how to graph one inequality, and you can see a couple of examples of those here. They're considered inequalities because instead of just having an equal sign between them, they actually have inequalities greater than or less than, greater than or equal to, less than or equal to. So these are the things that you need to be looking for. If your inequality has the equal sign underneath it, the line you're going to draw is a solid line. If it doesn't, like these two here and here, no equal sign, it's going to be a dotted line. When we go through and graph these, we have to determine which side of the line we're going to shade on, and to determine which side, we're going to use something called a test point. And that will tell us whether or not the test point is true and whether or not the solutions on that side of the line are going to be true. So when we take a look at our first example here, you can see that we have two inequalities that we're going to graph. They're both y to the first and x to the first, so that means we want to eventually get them into some kind of y equals mx plus b form, but remember we probably won't have an equal to. It'll be greater than, equal, or greater than, less than, greater than or equal to, or less than or equal to. So when I look at the first question, I want to take this and get y alone, which means I'm going to do plus 1 plus 1. So y is less than 2x plus 1. Because it's just a less than sign, what I have here, it is going to be a dotted line. My slope for this line is going to be 2, or 2 over 1, and my y-intercept is going to be positive 1. So when I go to graph that line, just like we graphed previously, I'm going to go to a y-intercept of 1, and I'm going to count up 2 over 1, up 2 over 1, and I'm going to keep going until I go off the page, and then I'm going to go back in the reverse order. Down 2, left 1, down 2, left 1. So I end up getting these points here that are on the line. And then I'm going to want to draw a line through those, but remember in this case, the line that you draw has to be a dotted line. So when I go through to draw this dotted line, I'm going to take the line. I'm going to connect the line from this point to this point, and I'm going to make that line dotted, I think. Okay, let's redo that then. That did not come through dotted like I expected that it would. What if I have that hit? There we go. There's my dotted line. So there's my dotted line. I want to make sure that on this dotted line I have an arrow on each end, and I need to decide which side of this dotted line is going to be shaded. To do that, I'm going to pick a test point, which is one point that's clearly on one side of the line or the other. I like to use 0, 0 as my test point, and in this case 0, 0 is truly on one side of the line. It's to the right of it. So what I do is I go back over to my inequality, write down that I'm doing 0, 0 as a test point, write down the inequality, and then substitute 0 in for x and 0 in for y. So this is 0 minus 1 is less than 2 times 0. Negative 1 is less than 0. That is a true statement. Since that is true, that means that 0, 0 is a solution for this inequality. And it also means that not only is 0, 0 one of the solutions, but that everything over on this side is also a solution. And just like when we graph lines, we have to make sure that we label. In this, I'm going to label on one of the shaded lines, shading lines I should say, y minus 1 is less than 2x. I also have to remember to label the x and y axis. Sometimes I remember to do it first, sometimes in the middle, sometimes I forget and don't do it till the end. And then I also have to graph this other one. So the first one is done. I'm going to go back now and graph the second one. This is already in our y equals mx plus b form. In this case, my slope is 1/2. My y-intercept is 0. I had to force that 0 in there. If you don't see it, it's a plus 0. And because my inequality has an equal to on it, it is going to be a solid line. So I'm going to go to 0, 0. And then I'm going to move up 1 over 2, up 1 over 2, and you can see I'm making those points on my graph, and you can go down 1 to the left 2 as well. And then I want to draw that line. And again, if we're drawing that line, please remember, it is going to be a solid line in this case. So I'm going to pick up a solid line, and I'm going to connect it from this point here to this point here. There's my solid line. So I'm going to want to put arrows on the end of this. And the same thing is going to happen with this one. I've got to pick a test point. In this particular case, we cannot use 0, 0. I'm going to put a little note here. Cannot use 0, 0 as our test point because the line passes through it. So I've got to pick a different test point. And my options are limitless. I can pick any point I want as long as it's on one side of the line or the other. So I'm going to take a look at this and say, well, with respect to that solid line, if I was to pick the point 2, 2, it is clearly above the solid line. So I'll do a test point with 2, 2. Your test point could be done with a different number, different point. It depends on what you pick. So my inequality, and I just wrote 0, 0. My inequality for the test point, 2, 2 I said, 1/2 x. You could put a plus 0 there. I substitute this in for x and this in for y, so 2 is greater than or equal to 1/2 of 2. And we know that half of 2 is 1, and that 2 is greater than or equal to 1, so this is true. So that means when I go to shade, I'm going to shade this, and I'm going to shade all these other points that are on that side of the line. So if 2, 2 is a solution and it's above the line, then all the other points above the line must be solutions as well. If your test point turns out to be false, you would shade the other side of the line that the test point is not on. In this question, it says to label the solution set as S, and you can see we have this area that's over here. It's shaded plaid. I say it's like Mr. Rouse plaid pants. It's plaid, it's got crisscross of color, the colors don't always match. That is the solution set for this particular problem, where the area of the graph where both colors have shading. So we label that with an S. And then it also says to name one point in the solution set. You can pick any point that sits in there. I'm going to pick the point 1, 2, 3, 1, 2. I'm going to pick 3, 3, this point right here. So the one point in my solution set that I'm going to name is 3, 3. There's an infinite number of points that you could pick. That just happens to be the one that I pick. You could pick something different. When we go on to the next one, turn the page, there are 2 more inequalities that you're asked to graph. I'm going to go through, graph them. Please follow along or try it on your own and then come back and check your work. So it's your decision on what it is that you want to do. So for the first one, I want a minus 3x from both sides. So I get negative 6y is greater than negative 3x plus 12. I'm going to divide by negative 6. You have a rule that you learned previously that anytime you divide or multiply by a negative number, you have to flip the sign. If it's greater than, it becomes less than, etc. So in this case, because I'm dividing by a negative number, my inequality is going to have the flipped sign. Instead of greater than, will be less than. It is going to be a dotted line because of not having an equal to under it. The slope will be 1/2. The y-intercept will be negative 2. So I go to negative 2. I go up 1 over 2. This is going to be, like I said, a dotted line. So I'm going to go to pick up my line. It's going to be dotted. Let's make it the same pretty color that we're using. Hopefully this works. I haven't quite figured this out yet, but we'll see. So I'm going to draw this dotted line. Okay, I'm going to go back. Whoopsie, put the arrow on it. I have to pick a test point. 0, 0 is a legal test point to use for this particular question because the line does not go through it. So for my test point, I'm going to put 0, 0. The original inequality, 3x minus 6y is greater than 12. 3 times 0 minus 6 times 0 is greater than 12. 0 minus 0 greater than 12. 0 is greater than 12. True or false? When you get to this point, you have to say to yourself, is this true or is this false? And this is true. I'm sorry, this is false. I guess I'm having one of those days. So I'm going to put that this is false, which means 0, 0 is not a test point. If 0, 0 is not a test point, nothing else on that side of the line is a test point, which means all of your solutions are going to be over here. So none of the points on the same side as the test point are going to be solutions. I think I said that wrong a minute ago. All of your solutions are going to be on the other side. And we want to write our original inequality, 3x minus 6y is greater than 12. Label the x and the y. And then I'm going to do the same thing with the other inequality. So when I move on to the other inequality, I need to get y alone, which means I'm also going to start this by minusing 3x. Negative y greater than or equal to negative 3x plus 2. Divide by negative 1 to get the y alone. Y is less than or equal to 3x minus 2. Because of the equal to, when I graph this, it'll be a solid line. The slope, 3 over 1. The y-intercept, negative 2. So I'm going to negative 2, and I'm going up 3 over 1, up 3 over 1, etc., the whole way through. And when all is said and done, I do want to draw a line, and my line that I'm going to draw will be in this color, and it will be a solid line. So my solid line that I draw is going to go like this. Arrows on the ends. I need a test point. I can use 0, 0 again in this case. Please notice 0, 0 is not on the line. So when I test point with 0, 0, I have 3x minus y greater than or equal to 2. 3 times 0 minus 0 greater than or equal to 2. 0 minus 0 greater than or equal to 2. Is 0 greater than or equal to 2? True or false? 0 is not greater than 2, so that's false. 0, 0 is not a solution, nor are any of the points on that side of the line. So if they're not on the side of the solution of the test point, your solutions are on the other side. So in this case, your solutions are over here. I'm going to write the equation on one of those shaded inequality lines. In this case, when they tell me, I'm assuming, when they tell me, oh, these directions probably go with the other one, to graph your inequality and label your solution set. In this particular case, my solution set is over here. You're not really supposed to draw this in, but just so we're all in the same place, your solution set follows this inequality, and it's everything in that area kind of from there over. Because this line is a solid line here, every point on that line is part of the solution. Because the dotted line, the purple one, is dotted, the points that sit on there are not parts of the solution set. So if they tell us to name a point in the solution set, we cannot pick a point that sits on that dotted purple line. Clearly pick one that's in the area. So let's suppose I go right 4, down 4. Here's a point. So the point 4, negative 4 is part of the solution set. Let's go ahead and move on to the last question that's here. These are horizontal and vertical lines. If your equation only has a y in it, it's considered a Hoy line because of the y, and the h means that it's a horizontal line. Other than that, the rules are pretty much the same. We're drawing a horizontal line that crosses at 2. What does it cross at 2? It crosses the y-axis at 2. So I'm going to go to the y-axis at 2, draw a horizontal line. This tells me it's solid. So basically, it's going to be a line that passes through these points that you see here. Pick whatever one you want. A line, horizontal, passes through those points. There it is. And I want numbers, y values, that are greater than or equal to 2. So that means I'm going to be shading up above this line. Everything up here is in the solution set. We can just use the inequality to do this one. Greater than or equal to 2. So this is, in this shaded area, y is greater than or equal to 2. I'm going to label my y-axis while I'm here and my x-axis. For the second one, it is x is less than or equal to 3. This is what I consider a Vux line because of the x. This tells me it's a vertical line. So I'm drawing a vertical line that crosses the x-axis at -3. So I'm going to -3, and I'm drawing a vertical line. Because of this, it's going to be a dotted vertical line. So I'm going to go here, and I basically have this dotted line, and I want numbers that are less than or equal to that, just less than. So I want points that are over here, so the solution set to this one is going to look like this. They want to know what the solution set for the whole entire thing is. Your solution set for the whole entire thing will be this area that's here, where the plaid area is. Remember, it's got to look like Mr. Rao's pants. When I do this, I don't want to forget to write the inequality here, and I don't want to forget to pick a point in the shaded section. So if I pick a point in the shaded section, I could go -4, 4, which is right here. -4, 4 is a point in that solution set. So there's quite a few rules on this one. You need to make sure you're paying attention and you know exactly how to graph these. Again, it should be reviewed from last year, but the graphing is a little particular. Pay attention, solid or dotted. Use your test points to tell which side of the line you're shading on.